Hi students, again I come back for the next video. Last class we discussed about the charge, and we know that there is a force act between the two charge particles. You know the force of attraction or repulsion between the two charge particles. From class 8 or class 7 you know about that. The two same type of charge repels to each other and two opposite type of charge attract to each other. So if any force is acting between the two charge bodies, there may be same types of charge or maybe the opposite types of charge. How much force will act between them? That idea was given by the Coulombs, and that is known as the Coulomb's law of electrostatics. Now we discuss about the Coulomb's law of electrostatics. Actually, what is the Coulomb's law of electrostatics? Now we discuss. So suppose one charge here, Q1 is one charge, and there is another charge Q2, and the distance between these two charges is R. So according to the Coulomb's law of electrostatics, the force acting between them is if F, this force of attraction is directly proportional to the product of the two charge body. So F proportional to Q1 into Q2, and also F is inversely proportional to the square of the distance between them. Now if we combine these two equations, combine these two relations, then we'll get F proportional to Q1 Q2 by R square. So now if you want to replace this proportional sign by the equal sign, then we take a constant. So from this equation you can write F is equal to K Q1 Q2 by R square. This K is known as the proportionality constant. In CGS system, the value of K is 1. So we can write F is equal to Q1 Q2 by R square. But in SI system, this K is equal to 1 by 4 pi epsilon naught. Therefore, the F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. This epsilon naught is the constant. This is known as the permittivity of the free space. So this is the Coulomb's law in SI system, and this is also Coulomb's law in CGS system. Now this epsilon naught, now from this Coulomb's law you can define the unit of charge. At first we will discuss about what is the unit of charge. So when we discuss about the unit of charge, at first we have to discuss about what is the value of this 1 by 4 pi epsilon naught. The value of 1 by 4 pi epsilon naught is the 1 by 4 pi epsilon naught is equal to 9 into 10 to the power 9. 9 into 10 to the power 9 Newton meter square per coulomb square. Newton meter square coulomb to the power minus 2. This is the unit of this epsilon naught. So from if you put this 1 by 4 pi epsilon naught, this is the value of this 9 into 10 to the power 9 Newton meter square per coulomb square. Now if this Q1 is equal to Q2 is equal to Q, we assume it that Q1 is equal to Q2 is equal to Q, and the separation between them is 1 in SI system, that is 1 meter, and the force between them is 9 into 10 to the power 9 Newton. So I repeat once more, two charge bodies Q1 and Q2 both are equal to Q, and they are separated by the distance 1 meter, and the force, electrostatic force acting between the two charge body, that is 9 into 10 to the power 9 Newton. Then from the Coulomb's law we can write we know that F is Coulomb's law, F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. Now we will put these things in this equation. So from this you can write F is equal to what? 9 into 10 to the power 9. What is the value of 1 by 4 pi epsilon naught? Also 9 into 10 to the power 9. And Q1 and Q2, that means Q into Q, and R means 1, so 1 square. So from here you can write this 10 to the power 9, 10 to the power 9 cancel, 9 and 9 cancel. So you can write Q into Q means Q square is equal to 1. That means Q is equal to plus minus 1, and this charge is 1 coulomb. So what is the definition of 1 coulomb charge? 1 coulomb charge means if two charge bodies having the same charge, and if they are separated by the unit distance, that is 1 meter, and if the force acting between them is 9 into 10 to the power 9 Newton, then that two charge is known as 1 coulomb. That is plus minus 1 coulomb. That may be plus 1 coulomb charge or maybe minus 1 coulomb charge. So from this Coulomb's law we know about the unit of charge, that is 1 coulomb. We can define what is the 1 coulomb from the Coulomb's law of electrostatics. Now we can define this Coulomb's law in vector form. We can define the Coulomb's law in vector form. Now we'll discuss about the vector form of Coulomb's law. Now one expression is there to represent the Coulomb's law in vector form. See one thing, set one 3D xy z axis, 3-dimensional axis, the 3 dimension, and one charge Q1 is here and Q2 is here, where the position vector of Q1 is R1 and the position vector of Q2 is R2, and the distance between Q1 and Q2, that is defined by the position vector R12. Now from this diagram, if you see, then you can have the three vectors R1, R2 and R12. Now from this triangle you can say that in this triangle this R1 and R12, these are along the same order, but R2 is along the opposite order. So if you apply the triangle law of vector addition, here from the triangle law of vector addition, we can write the R1 plus R12 is equal to R2 vector. Simply the triangle law of vector addition. So from this equation you can write R12 is equal to R2 minus R1. Then from the Coulomb's law, we know that from Coulomb's law, if already have in vector form, vector F is equal to 1 by 4 pi epsilon naught q1 q2 by r square. At the place of r we put this distance r12 in scalar form. R12 is the what magnitude of the r12 vector, so r12 square, and here we put that r12 cap. So what is this r12 cap? R12 cap, this is the unit vector of the r12. So here I just change the r square by the term r12 square. Here r12 is the magnitude of the vector r12, and here we multiply this by r12 cap. Here r12 cap, that is the unit vector of r12 that denotes the direction of the force. So this is the vector form of the Coulomb's law. Now we know that r12 is equal to r2 square, r2 minus r1. So at the place of r12 we can write now r2 minus r1, and that is within the modulus. Why? Because we take the magnitude here and then whole square, and that is r12 cap. So this is the vector form. This is the vector form of Coulomb's law. This is the vector form of Coulomb's law. Next we go for the next topics. So now we know about the Coulomb's law. So if two charge bodies, here the Q1 and Q2, these two charge bodies are separated by the distance r. Thus they are separated by the distance r, and this is in free space. Free space. And same two charge. Same two charge Q1 and Q2, they are separated by the same distance, but they are in a particular medium. Any medium, not the free space. So according to the Coulomb's law, for this case, the force F is equal to 1 by 4 pi epsilon naught Q1 Q2 by r square. But here, as the medium is changed, here the medium is not the free space, any particular medium. So what is the force here? F is equal to 1 by 4 pi epsilon Q1 Q2 by r square. So in this case, at the place of epsilon naught, we put the epsilon. What is the epsilon? Epsilon is the absolute permittivity of this medium. Here, when the permittivity of the free space was epsilon naught, that time we put here epsilon naught. But here, as the medium is changed, now this is the different medium, not the free space, and here the permittivity, absolute permittivity of that medium is epsilon. Now the force is also changed. Here epsilon is not is changed by epsilon, and this is the force acting between the two charges when they are placed in the different medium. Another things, if you compare this permittivity, absolute permittivity, with this permittivity of the free space, then we get the relative permittivity of that medium. So what is the relative permittivity of the medium? Relative permittivity of the medium. Suppose we take this, that epsilon r. So epsilon r is equal to epsilon by epsilon naught. That means relative permittivity of that medium is the ratio of absolute permittivity of that medium to the permittivity of free space. This is known as the relative permittivity, and here I define it by the term epsilon r. So from here you can write epsilon is equal to epsilon r into epsilon naught. So such a way, if any medium is given and the relative permittivity of that medium is given, then you can use this formula. One example now I will give, then that will be clear to you. Here one thing, the value of this epsilon naught, that is the permittivity of the free space, that is 8.85 into 10 to the power minus 12 Coulomb square Newton inverse meter to the power minus 2. This is the the value of this epsilon naught, that is the permittivity of free space. Now in question, suppose the relative permittivity, another name is the dielectric constant. So relative permittivity of water is given 80. Question is the relative permittivity of the medium is of the water, suppose, is 80. So what is the absolute permittivity of the water? In the question, 1 marks question, the relative permittivity or the dielectric constant of water is 80. Calculate the absolute permittivity of the medium. So just we put this formula. We know that epsilon r is equal to epsilon by epsilon naught. So from here epsilon is equal to epsilon r epsilon naught. So what is the value of the relative permittivity? 80. So at the place of epsilon r we put just 80, and what is the value of epsilon naught? This one. So that is 8.85 into 10 to the power minus 12. So if you calculate it, then you will get the absolute permittivity of the medium. Here now we represent this relative permittivity or the dielectric constant of any medium in different way. Suppose the two charge Q1 and Q2, they are separated by the distance r in free space. So what is the force? F0 is equal to 1 by 4 pi epsilon naught Q1 Q2 by r square. And the same two charge Q1 Q2, they are separated by the same distance r, and now they are separated in a particular medium where the permittivity, absolute permittivity is epsilon. So same two charge Q1 Q2, the two charges are same and they are separated by the same distance, but difference is at first they were placed in the free space, and for the next case they are placed in a particular medium where the absolute permittivity is epsilon. Now if you do that F by F0, if you do that F by F0, what is the value of F? 1 by 4 pi epsilon Q1 Q2 by r square, and F0, that is 1 by 4 pi epsilon naught Q1 Q2 by r square. So this 1 by 4 pi cancelled, this Q1 Q2 by r square, Q1 Q2 by r square cancelled. So from here you can write F by F0 is equal to epsilon naught by epsilon. So if you reverse this, F0 by F, that also be reversed, that is epsilon by epsilon naught, that is equal to the relative permittivity of that medium, we know. So we can define the relative permittivity or dielectric constant of any medium such a way that relative permittivity or the dielectric constant is the ratio of force between the two charged body when they are placed in free space to the force when they are placed in that particular medium. Both cases the separation is same. I repeat once more, the relative permittivity is the ratio of F0 by F. Relative permittivity is the ratio of F0 by F. That means F0 is the force between the two charged body when they are placed in the free space, and F is the force between the two same charged body by the same separation when they are placed in the particular medium. Now the force, the ratio of these two forces is known as the relative permittivity. So we can represent the relative permittivity in two ways. Relative permittivity is the ratio of absolute permittivity of that medium to the absolute permittivity of the free space, and also the relative permittivity is the ratio of force between the two charge when they are in the free space to the force when they are in that particular medium both cases the separation is same. So this is the Coulomb's law. So from the Coulomb's law, we get the idea about the force acting between the two charged body, and if the medium is changed, how the force between the two charged body is changed. That idea also we get from this Coulomb's law. And from the Coulomb's law, we also know about the what? The definition of 1 Coulomb charge. So this is all about the Coulomb's law. Now the another small things we'll discuss today, and our class will be over for today. That is the electric field. Electric field means suppose this is a charged body. This is a charged body, and if you place another charged body here, then this charged body will feel a force due to this charged body. And if you put another neutral body, that also feel a force by this charged body. But if you place this charged body here and another neutral or any charged body, if you place at a large distance, then this charged body can't apply any force to the next body. That means we can say when you place this charged body, then around this charged body a certain area will be created, within which if you put or if you place another charged body or neutral body, then that will feel a force due to this charged body. So electric field of any charged particle or charged body means a certain area around this charged body within which the effect of the charged body will act. This is known as the electric field of a charged body. Now, if I say what is the electric field intensity or the electric field strength? Electric field strength or the electric field intensity is that suppose this room is an electric field, and in this room if you place here suppose 1 Coulomb charge plus 1 Coulomb charge, a positive unit charge. So within this electric field, when you place a plus 1 Coulomb charge or positive unit charge, then this will feel some force on it. That may be attractive or may be repulsive. That depends on the types of electric field. But some force will act on this unit positive charge. This force is known as the electric field intensity of this electric field. So simply we can say that when a positive unit charge is placed in an electric field, then it will feel a force on it that is known as the electric field intensity of the electric field or the electric field strength of that electric field. Okay, today up to this. Next class we will discuss about the next topics. Thank you.